University of California, Berkeley, year 2009. A group of researchers sat together and worked on a project called AmpLab and developed something called Apache Spark. And from that point, rest is history. If we look at the evolution of Spark from that time, in 2009, those researchers sat together and Matt Zaharia was the key contributor towards Spark, and he was recognized as the creator of Spark. A year later, Spark was open sourced and it was released to the public. In 2013, it came under Apache Software Foundation and it became Apache's top level project. Now, Spark is world's most widely used engine for scalable computing. In fact, 80% of Fortune 500 companies use Spark. Some of the prominent names including Apple, Microsoft, Meta, Amazon, Netflix. And the source of this info is Spark's official website. Well, not only these names, in fact, Nvidia, which is taking the world by storm through its powerful AI chips, which are used heavily for generative AI technology, is using Spark. That is very impressive. Well, that also brings up a question. What is Apache Spark? Instead of going into the definition, theoretical definition, let's understand it practically with an example. Suppose there is a very big retailer called World, and this retailer has its stores across the entire USA. Customers just love to shop in its stores and are very loyal as well. The CEO of this company wants to know which are the top 3 highest selling stores, which are actually these. To find this information, we have all the store sales data, which is of the size 2 terabytes. To use Spark to solve this problem, we'll have the store sales data. What we need is to create a Spark cluster and write some Spark code and run it on this cluster. It would read the data and give back to us those 3 top selling stores. I hope that gives you some idea about what Spark is. But still, let's look at the proper definition of Spark. Spark is an open source multi-language unified computation engine designed for large-scale distributed data processing. Don't worry if this is too much to consume at once. I understand, because I'm gonna break this down into several parts and explain each of them. Let's do that. One is open source, multi-language, distributed data processing, large scale, and unified. Let's look at all of these one by one. I'll keep unified for now towards the end of this video. So just be a little patient and I'll cover unified aspect as well. But for now, I'll focus on these 4 points, which are open source, multi-language, distributed data processing, and large scale. Let's start with open source. So Spark is an open source technology. It is under Apache Software Foundation. To download Spark, you need to go to its official website and just choose a particular Spark release, choose a package type which is appropriate, and just click on download Spark. It is that easy. Now, what do you need to run Spark? Well, you need a machine. From operating system point of view, you can use either Windows or Unix. It supports both. From Unix, you can use either Linux or Mac OS. But what is the prerequisite? You definitely need to have Java installed on your machine to use Spark. Always remember that. How to run Spark in cloud? Well, that's a very good point, because in today's world of cloud providers like AWS, Azure, GCP, we don't always need a physical machine to do our computation. We can always create instances in cloud. Same goes for Spark as well. You can run Spark in AWS or GCP or Azure. Let's take a look how we can do that. In AWS, you can simply create an Amazon EMR cluster which offers you Spark, and they keep updating the Spark version to match with the latest version available. In Azure, you can simply create a HD Insight cluster which offers you Spark as one of the service. Within GCP, you can create a Dataproc cluster, and it even offers you Spark performance enhancements. Databricks. It's interesting. If you're not aware of Databricks, it's a company which was started by Spark creators, and this is a provider which is completely backed by Spark. So in Databricks, you can create a compute cluster and you'll have Spark available. Now, multi-language support. Spark itself was originally written in Scala. So it supports Scala as a coding language, but it is not the only language because you can code in Java or Python and even R. Now let's take a look at distributed data processing aspect of Spark. Within Spark, it has a concept of master, which is also called a driver, and workers. And these workers are also called executors. How it works is, the master, if it has to process some data, so let's say you want to process data using Spark, what master would do, it would divide that data set among different workers and break it into chunks. And these are always logical chunks, not physical chunks. And it assigns each worker a respective chunk from that data. And when the execution starts, each worker executes on its own chunk of data and gives us the result back. Distributed data processing is a technology in itself, and I have created a dedicated separate video on this technology. So please feel free to check that out. Spark has large scalability. An idea about its scalability can be derived from the fact that within AWS, you can create a cluster, an EMR cluster with Spark installed on it, and you can keep 2000 instance cluster, each of close to 2 terabyte of memory. I mean, can you imagine almost 2 terabytes of memory with 2000 instances? I mean, that's huge. Meaning, you can horizontally scale any Spark cluster. You need 6 instances, that's okay. You want to add more, you can add more. You have more data to process, you can add more instances. Keep on adding and scale it horizontally. And keep on adding, and you can add and create a cluster of about thousands of instances. Well, a key question still arises. What was unique about Spark which made it so popular? I mean, that's an excellent question. Why? Because if distributed processing and scalability were the only factors, there was a very popular technology around that time, Apache Hadoop, which gained immense popularity. Hadoop became extremely popular and it gained wide adoption by different companies across the world since it was launched. But something happened to Hadoop around the time in the year 2014 when Spark started gaining its popularity. And Hadoop's popularity started to decline. And that brings up a very important question. Why Hadoop lost its popularity? I mean, Hadoop was very widely adopted by the whole world and by the tech giants. What happened suddenly to Hadoop after Spark was launched? And Spark gained its popularity rather. That Hadoop lost its popularity. And this is a very important question we should all ask ourselves to understand Spark better. And this is what I'm going to focus on for you. Hadoop's key 3 drawbacks which made it lose its popularity. First, Hadoop's MapReduce programming model. MapReduce was still simple to express useful programs in, but still was not too simple. Well, this is a broad statement. Let's look at it with an example. So what we want to achieve here is, we have this input data with some words in it, and all we want is that word and the count of that word in this input data. Such as ball. If we focus on this, ball occurs twice. So what we want as the output is ball with 2. Similarly, cat 3, dog 2, pencil 2. If it still doesn't make sense, just please pause this video and focus on this input data and final result, and then proceed with the video. We'll look at it using MapReduce. Now, to solve this such a simple problem, What MapReduce required you to do was, you have to first split your data into splits, such as these 3 splits. Then you had to go through a map phase, which required you to convert your data into key values, and that was a prerequisite. Meaning here, dog 1, ball 1, pencil 1, dog is the key and 1 is value. Then it had to go through a shuffling phase. And then there was this reduce phase, which used to count the number of occurrences for each key. And then the final result was produced. Now, this wasn't the best solution. Let's understand it. Why? If for our world retailer, if they want to understand, okay, for their customer residing in Texas state, which are the 3 nearest store of that customer? For this small problem, what they needed to do is to write a MapReduce program, because Hadoop required you to convert problem into MapReduce. So for this simple problem, what it required was to write a mapper and a reducer, and inside each you would have to have a map and reduce functions. Well, I'm not saying that every problem required you to write a reducer as well. I myself have written map only programs as well. But converting every problem into MapReduce was a bit cumbersome, and it became a bottleneck for several organizations at some point of time. Second drawback: Hadoop's disk-based operations. Hadoop used MapReduce, and MapReduce transient data was always stored on local disk. So its programming model didn't utilize memory very efficiently. Instead, the operations were more of disk-based. And these disk-based operations became a bottleneck at one point, and people started thinking twice before starting to use Hadoop. Third drawback: machine learning and graph processing. These 2 areas were the ones which Hadoop was not best suitable for. So, MapReduce paradigm makes repeated querying of dataset very difficult. It was just the way it was designed. And machine learning requires multiple passes through a dataset. Similarly, in graph, there are some iterative algorithms which have to revisit a single working set repeatedly several times. So, machine learning and graph processing were the 2 areas which Hadoop was not the best candidate for. So Hadoop, which was a giant elephant which captured the whole market at one point, started losing its popularity, and that was primarily due to slow performance. Now these were the 3 drawbacks of Hadoop. Now what benefits Spark offered? Let's look at 6 key benefits which Spark offered. We'll look at the secret sauce of Spark, which is lazy evaluation, how it helped us to do machine learning and graph processing, how it allowed us to easily code, and as I promised earlier, I'll cover unified engine also as part of this. Let's get started. First, unlike Hadoop, which was doing disk-based processing, Spark leveraged in-memory processing. Let's understand this statement. So, as part of MapReduce, MapReduce used to read the data from input data file, and the intermediate data it used to write back to the disk. Then the successive MapReduce used to read back the data from disk and in turn write the data back to disk. And then successive MapReduce job used to read the data from disk, and then the final data was written output. Whereas when it came to Spark, Spark leveraged memory. So it read the input data and wrote the intermediate data in memory instead of disk. The successive Spark job read the data from memory and wrote the data back into memory. Then Spark job would read the data from memory and finally wrote the output data. This utilization of memory was very efficient. And if we take a look at Spark API, we have a cache function using which you can directly persist the data into memory. This efficient utilization of memory, which was inherently and automatically done by Spark, made it extremely popular. In addition, it also offered us so many functions as part of Spark library for us to save the data into memory and in turn fetch the data from memory. This was revolutionary And this factor itself overcame all those slow disk-based operation challenges which Hadoop brought in front of us through its MapReduce programming model. So Spark came out as a superhero with efficient memory utilization as one of its superpower. Lazy evaluation. Well, I call it as a secret sauce of Spark. Laziness is never appreciated, but here laziness through lazy evaluation brings tremendous time saving and efficiency for Spark by avoiding unnecessary operations. Well, we'll understand all of these details through an example. But for now, can you look at the superhero on the screen? He's sleeping right now. Do you want to guess his name? His name is Spark. Yes. He's sleeping, but this is a very, very alert sleep, remember. And do not make a mistake of thinking he doesn't know what is happening around him. He's observing each and everything happening around him during the sleep. Just the difference is that being a superhero, he's not doing that action right now. And he has conveyed this clearly to us. He's saying, I'm not lazy. I know what to do. I'll wake up when real action is required. Remember this word action, because this is a core concept which helps us understand lazy evaluation. And this action is what the superhero is waiting for. So let's understand what action means. Spark has a concept of transformation and action. These are two kinds of operations. Well, let's take a look at transformation first. Suppose we have data of people with their name, age, and the city they reside in. And this data is sorted in ascending order by age. If I ask you a question, just filter this data and return back to me the rows with age greater than equal to 40. Well, these are these rows. That's simple. I ask you this question and you return back this data. So what has happened over here is there was this data and this operation returned back a transformed version of that data. Such an operation in Spark is called transformation, where the input is data and the output is transformed data. What is action? On this same data, if I ask you a different question now, okay, give me the count of rows in this data. Now, I'm not asking you to return me some rows. The count is 10. Or if I ask you another question, say, save this data as text file. Then you give me the output of text file. Such an operation is called action. I've listed a few transformations and actions examples on the screen, but these are just few out of all of the transformations and actions offered by Spark. And if you need the full list, I suggest you can easily refer Spark's official documentation to get the full list. So, this was the action which our superhero Spark has been waiting for. We now know action, but we still don't know how it is a secret sauce of Spark. And precisely, how lazy evaluation works. Well, let's take a look at it through an example of flights data. We have this flights data, which has 3 columns. The origin country from where the flight took off, destination country where the flight landed, and the number of flights between these two, origin and destination. The information we want from this data is the top 5 destination countries along with the number of flights. Well, I'm now going to share the SQL logic to find this answer, but if you would like to, you can surely pause this video and think about the SQL query to find the top 5 destination countries. Well, through SQL, all you need to do is just group this data on destination country name, do a sum of count column, sort this data in descending order, and do a limit of 5. And that should fetch you the top 5 destination countries. Let's see how we can do this in Spark. So we can achieve this using Spark SQL. Spark SQL is one of the components of Spark's ecosystem which provides us functions to run SQL queries in a distributed way on very large volume of data. So we first create a data frame on this flights data. This flights data is in the form of a CSV file for us, as you see on the screen. So all we need to do is we need to run a read function which reads this CSV data. Then we execute the same SQL logic which I just explained to you, which is we just do a sum on the count column, do a group by on the destination country name, we sort it in descending order, and do a limit of 5. Now these are transformations. Let's see when we run this in Spark SQL, how is it judged and formulated by our Spark engine superhero. So when we run a read transformation, it generates a data frame from the CSV file. At this point of time, our superhero, which is Spark engine, is sleeping because it's a transformation. It doesn't do anything. It's just looking at the transformations you are giving to it, and it is forming a lineage graph. When you run a group by and do the sum, similarly, it doesn't do anything. It is still sleeping and taking that alert sleep. Remember, when you sort it in descending order, it is still sleeping. And when you do a limit of 5 to find those top 5 countries, it is still sleeping and observing the whole lineage which you are passing on to it. And it is waiting for that action. And here show is that particular action. So as soon as it sees show, it runs this collect to return back the result. And this is the alarming point for this superhero. As soon as it sees that show action, it gets into action and it wakes up. And at this point, it wakes up and does the optimization to return back the results to you in the most efficient way. Well, this explains to us how lazy evaluation internally works. But we still have an open question we are thinking about. How is it even making Spark efficient? I mean, what efficiency benefit is it providing? Let me tell you, the benefits are huge. Let's understand it. So, if we have a data set of different people, we have their name, age, city they reside in, their email, date of birth, and this data set has 1 billion rows. In Indian numbering system, it's 100 crore rows. Imagine the size of this data. And the date of birth column is in format YYMMDD. And we are using Spark to convert this into DDMMYY format. Remember, this is just a transformation and not an action. And at this point, our Spark engine superhero is still sleeping and waiting for an action. As soon as we tell Spark, okay, display me 10 rows with converted date format, this is an action for it. And the alarm rings. And our superhero wakes up and thinks about the most optimized way to return the required result. And as part of this optimization process, in this case, it will think, okay, well, you're asking me to return back to you 10 rows with the date format conversion. You haven't asked me, okay, give me the 10 rows of the youngest people in my data or the oldest people. Because for that, I need to sort all of the 1 billion date of birth column values to find the youngest or oldest people. But you're not asking that. So why do I even need to scan all the 1 billion rows? So it does this efficiency calculation and just picks up 10 rows, converts them to DDMMYY format, and returns back the result to us. And this exactly is the efficiency we achieved through lazy evaluation, where it avoided the expensive scan of 1 billion rows of data. So, when we call a transformation in Spark, Spark engine doesn't just immediately start performing that operation. It is smart enough to just record whatever you are requesting it. It keeps a lineage of all the operations you are asking it to do, but it doesn't start just working on it. It is smart enough to take that judgment call. So, for example, if you run a sc.txt file, it doesn't start just keep loading that data without even looking at what you actually need. So it doesn't even load the data until it is necessary, until it has looked at that action you want to perform. So Spark uses lazy evaluation to reduce the number of passes, the number of visits it makes to your data. Well, how does it do this? So if in your Spark code, you're running different operations in different portions or segments of your code on one particular data set, what it will do, it will group all of them together to avoid again and again revisiting that data, which leads to costly read operations. So this is the kind of smartness and efficiency it provides us. Third, machine learning. Spark offered mlib. Mlib is Spark's scalable machine learning library. Well, using mlib, you can run different machine learning algorithms such as linear regression, logistic regression, and several others, not just these, on large volume of data in a completely distributed way. And this was 100 times faster than MapReduce. Well, in fact, a logistic regression performance benchmark was done between Hadoop and Spark. And when the benchmarking was completed, Spark took almost 100 times lesser time than Hadoop. Graph analytics. Spark offers GraphX, which is Spark's API for graphs and any kind of graphical computation you want to do. Basically, using GraphX, you can run different graph algorithms such as PageRank, connected component, motive finding. Just listing few out of all, there are several other algorithms you can use, and you can achieve graphical computation on your data in a very fast and distributed way. In fact, in a performance benchmark through PageRank algorithm on a 3.7 billion edges graph where 20 iterations were done, GraphX took the least amount of time when compared with other graph processing systems. Besides GraphX, Spark also offers another graph processing solution, which is Graph Frames, which is a data frame based graphical solution and which is also very optimized. Now comes easy coding. Well, remember the MapReduce algorithm, where for every problem you had to write a MapReduce program with mapper and reducers, which became really cumbersome and painful process? Spark relieved us from that. Let's take a look at that. Suppose we have a customer's data of a global company with all of the customer's details, including their first name, last name, city, country, phone number, and the company wants to know using Spark the count of distinct countries from where the customers are using its services. Let's use Spark to find this info. So using Spark, we first need to create a Spark session object. Spark session is the entry point for every Spark application. So we'll name our Spark session object as Spark. We can easily create it using builder and then calling a get or create function. Then we need to create a customer data frame. All of this data I just showed you is stored in a CSV file. So we need to call the read method and call CSV function on that and pass on the name of our customer's CSV file. And also setting header to true. And we want to infer the schema because we'll use the columns names for the computation we want to do to find the count of distinct countries. Now we want to run a select and select the column name. Let's look at the exact column, which is country. So we'll provide the country column name and then we'll do a distinct, and then we can run a count and we can easily print this. We can give a description, which is count of distinct countries. Let me correct this, distinct. And yes, we need to cast this into a string. It is this simple to code in Spark. And to execute this application, we need to use Spark Submit, which is a utility which comes with Spark's installation. And to this, we just need to pass our Spark application's name, which I have kept as main.py. We run this and we just get back our result. So the count of distinct countries is 243. Fifth benefit, unified engine. Spark provides us a unified engine, meaning using the same engine, you can run SQL queries, graphical computation, and even machine learning models. You don't need separate engines for each. How it helps? Well, within the same Spark application, you can process data by running SQL queries on it, then do some graphical computation on this data, and then run a predictive model on the same data within the same Spark application. Let's take a look at one such application. Within the same Spark application, we can include the imports for SQL, ML, as well as graphical computation. We can first create a data frame, then we can run some SQL aggregation on top of that data. Then from that result, we can create vertices and edges and run some Spark graphical computation, which is where we can run a PageRank algorithm on this data. Then we can use this data to create the features and even run a linear regression predictive modeling on this data. And this all happens within the same Spark application. And this is the unified engine benefit of Spark. Sixth benefit, real-time stream processing. Spark structured streaming is Spark's offering for real-time stream processing. You can also stream data from streaming sources such as Kafka. And one of the benefits is it abstracts away the complex concepts of streaming. And if you're familiar with Spark's API, you can build Spark streaming applications as well and process data in real time. In fact, Spark's official website explicitly mentions about how easy it is to use as it abstracts away complex streaming concepts. Spark's integration with third-party tools and technologies. Well, Spark is integrated with a wide range of third-party tools and technologies. I'll cover few out of all, but don't think of it as the entire list of all the technologies it has integration with, because it has integration with many more than what I'll be discussing here. Let's take a quick peek into some. From data science and machine learning space, it is closely integrated with scikit-learn, TensorFlow, PyTorch, MLflow, well, some of the most popular machine learning libraries. From analytics and BI space, it is integrated with Tableau, well, one of the most popular BI analytics tool which offers you visualization capability, Power BI, TBT. From storage and infrastructure space, it is integrated with Kafka, Elasticsearch, Airflow, MongoDB, Kubernetes, and many more. Hi, I hope you found this video helpful because your learning and growth is the goal of this video. Thank you for watching.